Hi everyone, this will be your video for sequences and patterns. This goes exactly along with your assignment for week 26. So here we go. So you can fill this in on your assignment, which is available on your Google Classroom, which brings you to the website called Easel, or you can fill this in by typing. If you're an in-person student, you've also received this in paper this week. So here we go. So first off, we have a little bit of vocab here, and we just need to figure out what a sequence is. So a sequence is a list of numbers that follows a particular pattern. So it's a list of numbers that follow a particular pattern, and we have two different kinds of this. We can have something that's called a finite sequence, and that's a function that has a limited number of terms. And an example of that would be, for instance, we would use curly brackets because it's just telling us this is a list of numbers and it's going to end, so it's closed. On the other hand, we have an infinite function, an infinite sequence, and that's a function with an unlimited number of terms. And that basically just means it does not end. So for instance, it'd be like 1, 2, 3, 4, ... Okay, so we also have terms, which is our set of values of the sequence, and that's also known as the range. Okay, so scrolling down, we have a table here that we can look at, and this kind of looks like an input-output table, so we could call something here like our top rack will be our domain, and the bottom will be our range. But what this also means for us when we're talking about sequences, our domain is also our term numbers, and our range are our term values. Okay, our last thing that we're talking about here is what this subscript means, and that just means it's the term number in the sequence. Okay, so we can use this table to solve two different types of questions that we see here. Our first one is asking us for what is a sub 2. So a sub 2 means I'm going to look for my second term. So that means that's what that a sub 2 means. So my second term is 4. So a sub 2 equals 4. Now on the other hand, they're asking what term in the sequence has a value of 8. So you look at your values, we look at 8, and it was our fourth term. So we would say n equals 4. So here we are on our next slide, and you can see that this is going to break our sequences down into even more depth. And we have two options here for our type of rules. So when we're talking about a rule, you can really think of that like an equation. Okay? So our first option that we have is something that's called a recursive rule. So something that's recursive depends on the terms in front of it. So basically what we can say is a rule for generating terms of a sequence that depends on one or more previous terms of a sequence. So it always is going to rely on something before it. So over here in our example, we have this little box that we could fill in, and we can say that this is our value. And then a sub n minus 1, that just means it's our previous value. Okay, so for instance, we can fill out the rest of this table using this idea, this recursive rule, which depends on the term in front of it. So essentially what we have, and I'm going to zoom in a little bit, this is asking for a sub 2 minus 1 plus 4, since n is 2. So that means we're looking for a sub 1 plus 4. Now we know that a sub 1 is 5. We get that from our table. So we do 5 plus 4 and we get 9. So you could keep doing this. So we have a sub 3 minus 1 plus 4, which is like a sub 2 plus 4, which is 9 plus 4, and we get 13. Okay, so again we have a sub 4 minus 1 plus 4, which becomes a sub 3 plus 4, and that becomes 13 plus 4, which is 17. And then you could probably see the pattern here for our last one. You could just even skip to the whole thing where you know it's the term before it plus 4, and we get 21. Okay, here we go. So let's look at an explicit rule. So something that is an explicit rule means that it can be used to find the nth term of a sequence, meaning that you don't need to have every term leading up into the one that you're trying to find. You could find the second term, or you can find the 22nd term without having all of the values in the middle. This a sub n over here, this is telling you it's the value that you are finding. So it's the value that you're finding. So let's look at this table and let's zoom in. You're going to notice this looks really similar to functions. You're going to be able to plug in your n, and then from that you can use your order of operations and get your a sub n out. So we have 4 times 2 minus 2, and that's going to be 4 times 0, which is 0. Then we have 4 times 3 minus 2, and notice that I'm just replacing my n. You can see it up here. I'm replacing my n with the number term that we're finding. Finding the third term, so I'm plugging in 3. So this becomes 4 times 1, which is 4. We have 4 times 4 minus 2, which is 4 times 2. We get 8. And last one on this table, we have 4 times 5 minus 2, which is 4 times 3, and we get 12. For instance, in this problem, if we were trying to find when n is, we'll say 8. I don't need to know the 6th or 7th term. What I do need to know is just how to plug this in. So I would be able to plug in 4 times 8 minus 2, which is 4 times 6. And when I get that answer, it's 24. So keep in mind that you can jump around, you can find specific values. You do not need every term to find the next. So in our last examples, they gave us the rules that we were working with. And remember, rules are kind of like equations here. And they gave them to us and they said, use these. Now we're looking at how to write our own. So let's look at recursive rules to start with. So we always have an initial condition, and that's basically a value or something that you need to get started. And for us, we need the value of the first term. So this relates each term after the first to the one before. So remember, recursive means that you rely on your previous terms. You need the terms ahead of the one that you're looking for. So we're going to write a rule for each each sequence, and we're going to find the next 4 terms. So for instance, we're just trying to look, how can I get from 3 to 8? I can do 3 plus 5, and that gives me 8. Then we can check to see if it works from 8 to 13. If I do 8 plus 5, I get 13. And you'll notice that it's going to keep working. If I do 13 plus 5, I'll get my 18. If I do 18 plus 5, I get 23. So you can see that clearly, if we're trying to write a rule here, we're going to take our previous term, remember that's a sub n minus 1, that's previous term, and we're going to add 5. So we can find some more terms here. We're going to add 5. We had 28. Add 5, 33. Add 5, 38. Add 5, 43. And you could keep going. Now notice that we can't just find the 10th term. We can't just find the 20th term. We would need every term along the way. When you are writing your rule, the one thing that you also want to make sure of is that you also say what your initial condition was. So this is when a sub 1 equals 3. So that is your final answer for number 1. Let's look at number 2. Number 2 is a little bit different, right? I can't just add a value each time. I'm noticing that my signs are alternating from negative to positive, from negative to positive. So that's giving me an indication that I am going to be multiplying by a negative. So we're going to have a sub n equals. I know we're going to be multiplying by a negative. Now we just need to figure out what number. So if I do negative 1 times negative 2, I will get my negatives, or I'll get my positive 2. And if I do 2 times negative 2, that works. And you can see that it will work again and it'll work again. So that means I'm going to take negative 2 times my previous term, a sub n minus 1. So we do want to make sure that we include our initial condition. So ours is when a sub 1 equals negative 1. Put a box around it. We do still have to find our next 4 terms. We're just going to keep multiplying by negative 2. So we'll get 32, negative 64, 128, and negative 256. Okay, so that's recursive rules. Let's look at explicit. So looking at the explicit rules, think of it more of like a function. So think of these like a function. Okay, and really what you can think of is like your n's are like your x's and your a sub n's are like your y. So when we're looking here, these are our y's, okay? We can always say that our n, or like what our x's are, it's gonna be like 1, so that's our first term. 2, it's our second term, and you get the idea. Okay, so those are our n's here. This n would be 6, 7, 8, 9 as we go forward. So we need to figure out how can we get from 1 to 5. Now remember, this has no sort of correlation between these values here. Okay, if we were writing a recursive rule, we would be able to say that if you take your previous term plus 3, you'll get your next term. Plus 3, it'll work. Plus 3, plus 3, plus 3. That's fine. But we're trying to write an explicit rule, meaning that maybe we're trying to find a future value. Maybe we don't want to have to rely on finding every single term. So a recursive rule was nice. Now let's do some explicit. For explicit rules, you need to be prepared to be wrong. Be prepared to do a lot of guess and check. Be prepared to be creative, okay? So we need to think about what I can do to get from 1 to 5. So for instance, maybe I just think, all right, I'm just gonna multiply it by 5 and see what happens. So if I do 1 times 5, I do get my 5. But when I'm testing my other points, it should still work for 2 and it should still work for 3. So if I do 2 times 5, I get 10. So right off the bat, I know that one's not going to be a good option. Let's try something else. So if I take my 1 and I need to somehow get it to equal 5, let's try to combine some sort of multiplication and addition. So if I take 1 and maybe if I want to add 2 to it, so far I'm at 2, I'm at 3, let me multiply that by 3. Let's see, so we have 3 plus 2, that works for us. So 3 plus 1, 3 times 1 is 3, plus 2 is 5. I like it. Let's see if it works for 2. 3 times 2 plus 2, so that's going to be 6 plus 2 is 8. I like it. That works. You could keep testing it. 3 times 3 plus 2 is 9 plus 2 is 11. That's also true. So I think we found it. So we would say a sub n equals, we would do 3n plus 2. And we don't need an initial condition because you can find any value without having your first value here. So let's find the next few ones. So for when n equals 6, n equals 7, n equals 8, and n equals 9. And we'll fill this in. So when n equals 6, we'll do 6 times 3 plus 2, we get 20. And I'm just going to fill in the rest. You could definitely take your time. You're going to fill in what you have. So for our very last one, it's the same exact idea, but we still need to figure out how to get from n equals 1 to 2, and n equals 2 to 5, and so on. So here we go. We have all of our n values, and we need to think. So if we're looking at n equals 1, maybe we figure, okay, if I do 1 plus 1, I do get 2, and that works for that. But if I do 2 plus 1, that only gives me 3, and that's not 5, so that doesn't work. So we need to think about something else we can do to make this work for us. Some sort of other operation. So for instance, if I square this 1 and then add 1, I also get 2. And if I square this 2 and then I add 1, I also get 5. So this could work. So let's try 3 just to make sure. If we do 3 cubed, 3 squared plus 1. Let's see, so it's 9 plus 1, that's 10. So far, looking good. So I think we figured it out again. We have a sub n equals, we're going to have n squared plus 1. Again, we don't need an initial condition because you can find any term. You can even be asked, what's the 20th term? And you're just going to plug in 20. All right, so let's just find the next few terms. So plugging in 6, we would get 37. Oops, I got a little messy there. Let's clean that up. So when you plug in 6, you get 37. When you plug in 7, you'll get 50. When you plug in 8, you'll get 65. And when you plug in 9, you'll get 82.